All right, hello again. Here is another video. I just figured more practice problems, the better. I got these all kind of set up for you. So I'm going to go through them so it'll help you on the homework and the exam. So the first problem, a man has deposited 50,000 in a retirement income plan with a local bank. This bank pays 9% per year compounded annually on such deposits. What is the maximum amount the man can withdraw at the end of each year and still have the funds last for 12 years? Okay, so in this particular problem, you have a present value of 50,000. You have an interest rate of 9%, and we're going to do 12 years. So we're looking for A, which are these up arrows, given P. Okay, finding out how much we can withdraw every single year for 12 years till it's depleted. So that's what we're looking for, A. And if I scroll down here, find A given P. So here is A on the left of the equal sign, and then here is the equation. Okay. I like to abbreviate it. It's A equals P, parenthesis, A over P, comma I, comma N. And then this is your fundamental equation, which is found on this appendix, or either appendix or table 3.6. A given P. Okay. So 50,000 A over P, 9%, and 12. Okay. You can find that in the appendix, or you can use this equation, put it in your calculator, and you get an annual amount of withdrawal of $6,983. Okay. Again, you deposit 50,000. What are the annual payments? Use this fundamental equation. All right. Next one. Oh, zoom in some more. A man purchases a new automobile. He wishes to set aside money in the bank account to pay the maintenance on the car for the first 5 years. It has been estimated that the maintenance costs are shown below. Year 1 is 120, year 2 is 150, year 3 is 180, year 4 is 210, year 5 is 240. Look, it's a pattern. They go up by $30. So that's key. Assume the maintenance costs occur at the end of each year and the bank pays 5% interest. How much should he deposit in the bank now so he can take that money out? So we have I is 5%, N is 5 years. A, that's the consistent or the first value throughout all of these, is 120. And look, G is the increase amount every year, it's 30. So what are we looking for? We're looking for P. Okay. All right. So what we have now is find P given A and given G, right? So A, P over A, comma I, comma N, that takes care of this 120. And then G is that same amount that increases, P over G, comma I, comma N. Okay. What do I have here? F over G equals F over P, P over G, F over A, F over G. Yep. That's just like a little side note for you. Yeah. We're looking for P given G. Okay. So in the appendix, we can find F over A at 5% at 5, which is 4.33. Multiply that by 120. We add it to the 30 times P over G, comma 5%, comma 5. This term in parentheses, 8.24 times 30. Add it together, we get $767. Okay. So again, find P given like an A and a G term. Now, you don't have to do it that way if you don't like G. You could, these are all what we call future values, right? 125, 150, 180, 210. And you can bring each one of those back to the present value. So these would be future. So find P given F, but you'd have 1, 2, 3, 4, 5 terms. This G is just like a shortcut. All right, next one. I think this is the last one. Yes. Okay. This is a good one. So how many years will be required for a sum of money to quadruple if it is deposited in a bank account that pays 6.75% per year compounded annually? All right, so we're looking for N. We want it to quadruple, and the I is 6.75% compounded. So just for sakes, I'm assuming P is $1 and F is 4, right? That's a quadruple. So P is P and F is 4P. So looking for N. Go here. We need to find N. Now, we could pick this equation that's boxed, or we can pick this equation over here. Doesn't matter, right? Because each one has P, F, and I, and the unknown is N. So what you have to do is you got to do a little bit of algebra to rearrange and solve for N. So I'm going to pick the one that's in boxed. So I divide by P, so F over P equals 1 plus I raised to the N. Then I'm going to log both sides. So we get log of F over P. The log rule states that N goes up front, so it's N log of 1 plus I. And then you can solve for N, which is log of F over P divided by log of 1 plus I. Put in your F and P from the givens, and you can then solve for N. So there are times where you got to use some algebra to rearrange the equations, okay? So we get 22 years. All right, this is the last kind of set of sample problems for Chapter 3. This should give you enough to finish Homework 2 and Exam 1. Thank you, and if you have questions, let me know.